Okay, so part C of this question asks to calculate the EMF induced into this rod. So first things, we have to, so EMF, Faraday's law, EMF is equal to, since it's just going through the loop once, we can ignore the negative end. So we have delta, the change in magnetic flux, change in magnetic flux over the change in time. And we know magnetic flux is equal to BA, or delta BA. So this is equal to delta BA. And since the B, which is the magnitude of the magnetic field, since that's constant, it's just going to be the change in area, right? So to calculate the area, well, let me just write this out. Okay, so to calculate the change in area, basically, we have this times this, essentially. And this is just going to be the velocity times the change in time, however long it takes to go across this, right? Which velocity times time is distance. So that would be this. Let me just write that velocity times change in time. And then this is obviously our D value. So then basically delta A is equal to V times delta T times D. So we can, I guess, substitute that back in. And we can see if we substitute this, we already have the delta T on top and bottom, so we can cancel that out. So we can just have delta B, or not delta B, because that's the A, hold on. So let me just rewrite this. E is equal to B times VD. And that's basically how to calculate the EMF induced into the cylinder. Okay, so the second part D is basically asking us to calculate the power dissipated. So we know that, so from the previous problem, we found out that the EMF induced is BVD. And so now that we're dealing with power, we know, and since it's a closed loop with the resistor, we know that we know velocity is equal to, or not velocity, sorry, potential difference is equal to I times R. And since the EMF we just calculated is BVD, we know BVD is equal to I times R. And so the formula for power, right, is equal to V squared over R. That's ugly, okay. And so we just substitute what we know V is now. So BVD, VD squared over R. And yeah, that's our power dissipated. So yeah.